Okay, show that sine x and cos x are linearly dependent or linearly independent. So I hope from our previous lessons I have explained how we can go about linearly dependent and linearly independent functions by using wronskian. So today too is another day for us to briefly look at this example. So since we show that sin x and cos x are linearly independent or linearly independent. So I will first take my f of x. So my f of x is my first term and my g of x will be my second term, which is cos x. Then I write my wronskian. So we use wronskian to the idea of wronskian to determine whether two functions will be linearly dependent or not. So this is when we find the wronskian of these two functions, sine x and cos x, and the result give us 0, then it is linearly and the result does not give us 0, then it is linearly independent. But when we find our wronskian and the result gives us 0, then it is linearly dependent. So this is how to find the wronskian. So we first write the terms that has been given, the f and the g on the first column. So write your f here, my g here. Then also you differentiate your f, then you write it beneath the f. Also you differentiate the g, then you write it below the g. Then after that, we do cross multiplication. We find the determinant. In finding the determinant, we multiply the leading diagonal. Then we subtract it from the multiplication of the other diagonal. So that's what we are trying to do here. Okay, so quickly we know that my f was given as this sine x, and my um and my cos x is so when we want to find the derivative of the f, so in finding the derivative of the f, we are going to get derivative of sine, which is cos x, which is cos x, cos x. Derivative of sine is cos x. Then also we try to find no, your gene 2 was given as cos x. Then we find the derivative of the cos x. And when you know that when differentiate cos x, we are going to get minus sine x. Then we multiply, that is the leading diagonal from this place, the diagonal, your f times your g prime. So my f, which is the sine x, times my g prime, that's the first derivative, which is the minus sine x. So when you multiply, you are going to get minus sine square x. Also, my other diagonal to the f prime times g, f prime times g, to make a substitution. Where is my f prime? So f prime times g. Where is my f prime? F prime is cos x. So you try to substitute it here, times the g. Where is my g? My g is cos x. So times cos x. So cos x times cos x, you are getting cos square x. Then you try to you take away all the differences. So my f times g prime, this is the answer I had, minus sine square x. and also my f prime gen 2, this is the answer I had, cos square x. So I take away, or I find a difference between them, and we are going to get minus sine square x minus the whole of this, which gave us cos square x. And we know that when we multiply 2 by -1, we are going to get sine square x plus cos square x. And more or less, sine square x plus cos square x is a function. It is an identity. So you know that sine square x plus cos square x is equal to 1. It's an identity. So wherever we have sine square x plus cos square x, you should take note that it is equal to 1. And you know that 1 is not equal to 0. So it makes the terms or the functions cos x and the sine x. Since the wronskian is not equal to 0, it is linearly independent. Thank you very much.